bioplastics with potatoes. Prepare a total of 8 potatoes that are roughly the same size. Steam them a bit, wash them clean, and then get a grater to mash the potatoes into a puree, which makes it easier to extract the starch granules from the potato cells. Just don't make it too fine. Otherwise, filtering later will be inconvenient. This way there shouldn't be any lumps, just a little dry. So let's add a bit more water. Prepare a glass bowl and a strainer, and pour the potatoes in to filter them once. Discard the solids, and just keep the water in the bowl. Stir it a bit, and rinse to extract as much starch as possible. After settling for a few hours, pour off all the liquid from the top and take a look. There's only this little bit of white thick substance left. When I pour it all into the beaker, it's not even 150 milliliters. Then, filter it again with a small strainer to remove all the solids. Stir it a bit, and rinse it again. And after settling, the liquid on top has turned black. Just pour it out, and don't scrape the potato starch from the bottom. Pour everything onto aluminum foil, and then put it in the oven to dry, removing the moisture that has seeped out. Done. There was still such a big pile, so I waited and got 37 grams of starch from 8 potatoes to prepare the glycerin. It's a colorless, thick liquid that adds sweetness, making the bioplastics more flexible and preventing them from cracking. Prepare a large beaker and add 100 milliliters of water, 15 milliliters of vinegar, and then 15 milliliters of glycerin. Give it a little stir to mix everything well. Continue to add 20 grams of homemade potato starch and heat it, stirring constantly to achieve the best effect. In this hot, acidic environment, the potato starch will bond together, forming a very cohesive polymer. After a few more minutes, it looks a bit transparent now, and the texture is very even, just like it's ready. Take it off the heat and pour it into a glass baking dish, doing it slowly. Spread it out evenly to cover the bottom of the dish, and let it dry naturally. After 3 days, look at how great it turned out. It's just like plastic wrap, and can be used to seal containers, blocking moisture and air. You can also add food coloring to make it look even better. Then pour it into the mold to shape it. But don't overfill it, just smooth it out a bit. It's not completely dry yet. It feels a bit wobbly like jelly. If you find the starch extraction process too troublesome, you can also just buy ready-made starch. Add hot water and stir it. There's really no special technique. Just add more water and more starch until you feel the consistency is right. It will turn into a non-Newtonian fluid, and you can scoop it up like this and play with it. It'll become a lump. This thing will become stronger when facing a strong opponent, but once it relaxes, it will lie flat. Then put it down. If it stays in place, that means you bought the right one. If it doesn't hold, you can also use 50 milliliters of lemon juice instead of the fuel, and you can add some food coloring and sugar to make it taste better. Pour it into the tray and spread it out. This time it turned out a bit dry, and the spreading wasn't done well, so it cracked right after drying. Luckily, there's still a larger piece here. Take your time and carefully pinch it down. You have to be very careful because if you mess it up, all your efforts could go to waste. This hole was already there, and the piece of bioplastic can wrap it nicely. Just press it down a bit to make it easier to eat. Well, it tastes pretty good, just like lemon-flavored pancakes. This biodegradable bioplastic can be metabolized by microorganisms and broken down into water and carbon dioxide, which is beneficial for protecting the environment. If you don't need it anymore, you can just dissolve it in water. You can also bury it in the ground like this, and the bacteria will take care of it.